Hey everyone, these are your notes for hypothesis, theory, accuracy, precision, and significant figures. Some definitions that you will need to know. Hypothesis is an attempt to explain phenomena. It can be a proposal or a guess, and it's used to understand or predict something. So a hypothesis is really just an educated guess. Theory is the result of testing and developing an explanation that is assumed to be true about something. So, a theory in the science world, if there's a theory about something, generally everyone believes it until it's proved otherwise or disproved. Theories are subject to change as new evidence proves or disproves that theory. So, some examples of theories that were debunked. You can talk about immovable continents. Prior to the middle of the 20th century, scientists believed that Earth's continents were stable and did not move. This began to change in 1912 when Alfred Wegener came up with the continental drift theory. And later, so today, it's now known as plate tectonics. So that's a theory that changed over time as we learned more. Some other definitions. Law is a concise statement that summarizes the results of many observations and experiments. So the difference is a law explains what is going to happen or what will happen, and a theory explains exactly why it happens. Okay, so accuracy versus precision, you will need to know the difference in these two. Accuracy is a measure of how close your measured value is to the actual value. So if you're looking at a target and you want to be accurate, you would have to hit the very middle of that target. Precision is a measure of how reproducibly you get the same answer if you measure something a bunch of times. So it's how often you hit the same target or the same spot that you've been hitting. So here's some examples. In the top left, those points are kind of all over the place. Only one of them hit the bullet point in the middle. So that would be low accuracy and low precision. Right under that, a lot of them got towards the center, so that's pretty accurate, high accuracy, but they're still kind of spread out. So we're gonna say low precision. In the top right, it's low accuracy because nothing hit the target or the middle point, but it's high precision because this person hit the same spot or pretty close to the same spot over and over. And then the last one on the bottom right, it was very accurate. They hit the target in the middle every time, and it was very precise. They generally hit the same spot. Okay, so let's talk about significant figures. I usually refer to them as sig figs, but this is basically how we round. A significant figure is a digit that represents an actual measurement. So there's rules for sig figs and how we count numbers. The first rule is all non-zero digits are significant. So when we're counting to see how many sig figs we have, we never count, we always count a number if it's not zero. So let's look at some examples. So the number 3, that's not a 0, obviously, so we have 1 sig fig. 9.4 would be 2 sig figs. 12.3 would be 3. The next one would be 4. The next one would be 5. Then we have 7, 6, and 11. So all of those are numbers that we count because they're not a 0. Rule number 2. Leading zeros are never significant. So zeros that are at the front of a number, we do not count them because they don't really matter. They don't really tell us much information. So if I have 0.2, I'm only counting that number 2. 0.703, I'm only counting the 3, so I have 1. 0.005, again, I'm only counting that 5, so I have 1. 1, then I have 2, then I have 3, then I have 5. Sorry, here we go. 5, 3, and last one has 7. Okay, next rule. Rule number 3. Captive zeros are always significant. So a captive zero is a zero that's kind of sandwiched between two numbers. It's kind of stuck there, so we will count it. 101, that zero's stuck in the middle, so we have 3 sig figs. Next one has 4, 5, 6. The next number, even if there's a decimal, those zeros are still sandwiched in between 2 whole numbers or 2 non-zero digits. So we're counting the whole thing. That would give me 7, 7, 8, 7, and 7. Okay, last rule. Trailing zeros are only significant if there's a decimal place in the number. So a trailing zero is a zero that comes after the non-zero digit. So for example, I have 100. The 1, we already know we're going to count because that's not a zero. But we don't have to count those 100s. So those zeros. So we have 1 significant figure. In the next one, I have 10.0. So whoever measured this 10.0 took the time to measure out to that tens place. So it's saying that it is exactly 10.0. In that case, we count all of it. So I have 3 significant figures. The next one doesn't have a decimal, so we say 1. Next one does have a decimal, so we say 6. 3, 3, 2, 2, and 3. Okay, these next few were for practice. Just remember all of your significant figure rules. So this first one, we do count the zeros at the end because there's a decimal. Same thing on the one after that. And same thing on the one after that. And the last one, there's not a decimal, so we don't need to count those zeros. There would only be 2 significant figures. Adding and subtracting sig figs. So whenever we do math and we add and subtract, the answer needs to have the correct number of significant figures. So to figure out how many that is, for adding and subtracting, we're taking the least precise number. So right here, 45 is less precise than 29.1. On 29.1, they took the time to measure to the 0.1. So that's a lot more precise than 45. 45 has 2 sig figs, so that means our answer should have 2 sig figs. So it would look like this. Basically, significant figures is telling us what place we need to round to or how many numbers we need to round to. Okay. Multiplying and dividing is pretty similar. The answer should be written with the same number of sig figs as the number with the fewest significant figures. So, in the question, I have 10, which is only 1 sig fig. And then I have 90.02344. That's a lot of sig figs. That's 7. My answer needs to have the least amount. So if I have 1 in this question, my answer will only have 1 significant figure. So it would look like this. Remember that 0 in front of the 0.1 doesn't matter because leading zeros never matter. So here's the note on that. Okay, there is a video if you want to go and watch it. It's also a little bit under this video, under the resources, so feel free to go and watch that when you have time. Lastly, we have SI units. SI stands for the International System of Units. This is what every science class ever will use. Almost every other country uses this as well. America is just a little different. Common units that you're going to see in this class will have seconds, meters, kilograms or grams, pascals, Kelvin, Celsius, liters, and moles. A few prefixes that you may need to know are kilo, deci, centi, milli, micro, and nano. Okay, that concludes these notes. Please email me or come to tutorials if you have questions.